Learn how to solve word problems on linear programming in this video. Linear programming. Okay guys, by now I think we have been familiar with certain linear programming terminologies such as the objective function and the constraint. So in this video, our main aim is to get the equation of the objective function and the equation of the constraint from a given word problem such as this. If you are still confused on what objective function and constraints are, check in the video description below. There is a link to the previous videos we have done explaining those terminologies. So let's take the first example. Example 1. A paint manufacturer produces two types of paint, one type of standard quality X and the other type of top quality T. To make this paint, he needs two ingredients, the pigment and the resin. Standard quality paint S requires 2 units of pigment and 3 units of resin for each unit made, and it is sold at a profit of $2 per unit. Top quality paint T requires 4 units of pigment and 2 units of resin for each unit made, and it is sold at a profit of $3 per unit. He has stocks of 12 units of pigment and 10 units of resin. Formulate the above as a linear programming problem to maximize profit. This is the end of the story. Okay guys, this question seems so complex, but you don't need to panic. Once it is a linear programming problem, word problem or linear programming, just follow this simple step. First, identify whether it is a maximization question or minimization question. So, at the end of this question, you can see that it says formulate the above as a linear programming problem to maximize profit. So from this, you can see that it is a maximization problem. Once it is a maximization problem, follow these steps. First, make a simple table like this: requirements, product, and available resources. So if you make this table, you then go to your question and find the particular product the question is talking about, the requirements necessary to make that product obtainable, and the available resources required to make that product. Let's solve this question. A paint manufacturer produces two types of paint, one type of standard quality X and the other type of top quality T. So from this first paragraph, you can see that a paint manufacturer produces two types of paint, standard quality and the other type, top quality. So you can see that the two products here is standard quality paint and top quality paint. Let's represent the standard quality paint with S, and let's represent the top quality paint with the letter T. To make this paint, he needs two ingredients, the pigment and the resin. So the requirements to make this product is pigment and resin. So pigment and resin. To make this paint, he needs two ingredients, the pigment and the resin. Standard quality paint requires 2 units of pigment and 3 units of resin for each unit made. So standard quality paint requires 2 units of pigment and 3 units of resin. So requires 2 units of pigment and 3 units of resin for each unit made, and it is sold at a profit of $2 per unit. So it is sold at a profit of, let's call the profit P. It is sold at a profit of $2 per unit. Top quality paint T requires 4 units of pigment and 2 units of resin. So for the top quality, it requires 4 units of pigment. So the pigment, 4 units of pigment and 2 units of resin, and 2 units of resin for each unit made, and it is sold at a profit of $3 per unit. It is sold at a profit of $3 per unit. He has stocks of 12 units of pigment and 10 units of resin. Therefore, the available resources the manufacturer have is 12 units of pigment. So pigment, available resources is 12 units, and available resources for resin is 10 units. Then the question, formulate the above as a linear programming problem to maximize profit. Once you can get this table in this format, you are done with the question already. This is the way to get your equations. To get your equation of constraint, the first equation of constraint, look at what to do. 2s plus 40 is less or equal to 12. Okay. 2s plus 40. You are using less or equal to because it is a maximization problem. If it is a minimization problem, you use greater or equal to. So this is a maximization problem, so you are using less or equal to 12. To get it, your second constraint, 3s plus 2t is less or equal to 10. 3s plus 2t is less or equal to 10. And to get your objective function, p, which is the profit, 2s plus 3t. So we can say that, let's write this in this format. The equation can be like this: maximize p, which is the objective function, is equal to 2s plus 3t, subject to the first constraint, 2s plus 40 is less or equal to 12, and 3s plus 2t is less or equal to 10. Don't forget your non-negative restrictions. S and T is greater or equal to 0. S is greater or equal to 0 because the manufacturer cannot produce a negative number of standard paint, and the manufacturer cannot produce a negative number of top paint. For instance, the manufacturer cannot produce -2 paints of the standard quality paint. No, the manufacturer can produce 0 standard paint. That is, he did not produce any standard paint, or maybe 1 standard paint, 2 standard paint. But the manufacturer cannot produce negative number of standard paint. The same with top paint. Okay guys, this is what we are trying to get. With this, we can now solve using any of the method, the graphical method, the simplest method. In this video, we are now solving this. Our main objective in this video is to get the objective function and the equations of the constraint. So when you are done with this, you will get this as your answer. These points A, B, C, and D forms the feasible region. They are the points that form the feasible region when you solve this. I'm not going to show us how to solve this in this video. So after calculating this, you will find out that the manufacturer needs to make 2 standard quality paint and 2 top quality paint to make his maximum profit of $10. If you don't understand how to solve this, check in the video description. There's a link where we have solved questions on maximization. You can watch the video and then come back to this one to complete it. Let's take the second example. Example 2. A furniture company produces inexpensive tables and chairs. But this must be a small company. The production process for each is similar in that both requires a certain number of hours of carpentry work and a certain number of hours of painting work. Each table takes 4 hours of carpentry and 2 hours in the painting department. Each chair takes 3 hours of carpentry and 1 hour in the painting department. During the current production period, 240 hours of carpentry time are available and 100 hours in painting is available. Each table sold yields a profit of 700 naira, and each chair sold yields a profit of 500 naira. Find the best combination of tables and chairs to manufacture in order to reach the maximum profit. Okay, you can see this is a maximization problem to reach the maximum profit. So this is the way to solve this kind of question. First, make this table: requirements, product, and available. You want to identify Go to the question and identify the products mentioned in the question, the requirements to make the product, and the available resources to make this product. Look at what this means here. Let's read the question again. A furniture company produces inexpensive tables and chairs. So the two major products here, or the two products we are talking about, are tables and chairs. So the two products, let's represent table with the letter T and chair with the letter C. So the two products now are tables and chairs. You want to find the requirements to make this product. The production process for each is similar in that both requires a certain number of hours of carpentry work. So the requirement to make table, it requires hours of carpentry work. Let's call this hours. Let's say hours of carpentry work. Let's represent, we see hours of carpentry work. And let's say hours of carpentry work in this format. And a certain number of hours of painting work. Let's say hours of painting work. Each table takes 4 hours of carpentry and 2 hours in the painting department. So each table takes 4 hours. So each table takes 4 hours of carpentry and 2 hours in the painting department. And 2 hours in the painting department. Each chair takes 3 hours of carpentry and 1 hour in the painting department. So each chair takes 3 hours in the carpentry and 2 hours and 1 hour, in the painting department. During the current production period, 240 hours of carpentry time are available. So the available resources, or let me say the available time for carpentry work is 240 hours and 100 hours in the painting. So for painting is 100 hours that is available for painting. Each table sold is a profit of 700 naira. So for the profit, for each table sold, the company makes a profit of 700 naira. And each chair sold is a profit of 500 naira. So for each chair sold, the company makes a profit of 500 naira. Find the best combination of tables and chairs to manufacture in order to reach the maximum profit. So the question says that find the number of tables and chairs to manufacture in order to reach the maximum profit. Once you have gotten your table in this format, look at what you are going to do. Get your first equation, your second equation, that is your equation of constraint, the first, and equation of constraint, the second, because there are only two here. So let's take the first one. 40 plus 3c is less or equal to 240. So 4t plus 3c is less or equal to 240. And for the second one, 2t plus 1c, which is just c, is less or equal to 100. Recall that you want to maximize the profit, so let's call the profit P. So P is equal to 700T plus 500C. So write the question in this format. Maximize P, which is the profit, is equal to 700T plus 500C. Subject to the first constraint, 40 plus 3c is less or equal to 240, and the second constraint, 2t plus c is less or equal to 100. T and c must be greater or equal to 0 because the company cannot produce a negative number of tables and the company cannot produce a negative number of chairs. So T and C must be greater or equal to 0. Therefore, tables and chairs produced must be greater or equal to 0. When we now get this, we can now solve this using the graphical method. So after solving this, we are going to get these points. We are going to get these points A, 0 and 80, B 0 and 0, C 50 and 0, and D 30 and 40. These are the points of the feasible region after plotting our graph. So after getting this point, we are trying to maximize. We can see that the objective function, which is P, is equal to 700C plus 500C. At point A, the objective function is 40,000 naira as the profit. At point B, 0 naira. At point C, 35,000 naira. And at point D, it's 41,000 naira. So the company is trying to know how many chairs and tables to produce to get the maximum profit. We can see that at point D, the company made their maximum profit of 41,000 naira when they produced, look at the table, when they produced 30 tables and 40 chairs. Therefore, the company needs to manufacture 30 tables and 40 chairs to make its maximum profit of 41,000 naira. Let's take the last example. Example 3. An agro-allied industry produces soaps and detergents. The industry needs two major components, surfactants and bleaches, for their production process. 5 units of surfactants and 2 units of bleaches are required to make a unit of soap. Similarly, 4 units of surfactants and 10 units of bleaches are required to make a unit of detergent. The company's budget for a period of 4 months is 200 units of surfactants and 300 units of bleaches. If the company makes a profit of 30 naira from each soap and a profit of 40 naira from each detergent sold, find the number of detergents and soaps the company have to sell for that period of 4 months in order to maximize profit. Okay guys, this is an example of maximization problem. As you can see, find the number of detergents and soaps the company have to sell for that period of 1 month in order to maximize profit. So in this question, we are trying to maximize the profit. Follow these simple steps. Just make a table in this format: requirements, products, and available resources. You can go through the question again to get it more clearer. You want to identify the products mentioned in this question, the requirements to make this product, and the available resources. That is the resources that are available to make this product. Let's go through the question again. An agro-allied industry produces soaps and detergents. That is the product this company have, or the products manufactured by this company is soaps and detergent. Let's represent soap with the letter S, and let's represent detergent with the letter D. So the major products they are talking about in this question is soap and detergent. Now you want to find the requirement to make this soap and the requirement to make the detergent. The industry needs two major components, surfactants and bleaches, for their production processes. Therefore, the requirements to make this soap and detergent are surfactants and bleaches. So surfactants and bleaches. Okay, 5 units of surfactant and 2 units of bleaches are required to make a unit of soap. So to make a unit of soap, 5 units of surfactant and 2 units of bleaches. 5 units of surfactant and 2 units of bleaches are required to make a unit of soap. Similarly, 4 units of surfactant and 10 units of bleaches are required to make a unit of detergent. So 4 units of surfactant and 10 units of bleaches are required to make a unit of detergent. The company's budget for a period of 1 month is 200 units of surfactant and 300 units of bleaches. Therefore, the available resources the company have for their production process is 200 units of surfactant and 300 units of bleaches. If the company makes a profit of 30 naira from each soap, so okay, let's take the profit. Let's copy P. If the company makes a profit of 30 naira from each soap, so look at soap, profit of 30 naira from each soap. and a profit of 40 naira from each detergent sold. Look at detergent, a profit of 40 naira. Find the number of detergent and soap the company have to sell for that period of 1 month in order to maximize profit. You can get your table in this format. Look at the next thing to do. First constraint, second constraint, and the objective function. Look at the first constraint here. First constraint, second constraint, objective function. So 5s plus 4d is less or equal to 200. 5x plus 4d, this is less or equal to 200 because the company have only 200 units of surfactant available. So the company cannot have more than 200 units of surfactant available. They have only 200 units of surfactant available for that production process for the period of 1 month. So 5s plus 4d, the surfactant used in the production of soap and the surfactant used in the production of detergent for that period of 1 month must not be more than 200 units. It will be either be less or equal to 200 units. Same with the bleaches. The company have a total bleach of 300 units for a period of 1 month. Therefore, the bleaches used or the number of units of bleaches used in the production of soap and in the production of detergent for the period of 1 month must not be more than 300. It will be either be equal to 300 or less than 300. Therefore, for the second constraint, 2x plus 10d will be less or equal to 300. And for the profit P, 30s plus 40d. Let's write this in this format. Maximize P, which is the profit, equal to 30s plus 40d. 30s, which represent the soap, plus 40d, which represent the detergent, subject to the equation of the first constraint. 5s plus 4d is less or equal to 200 units, which is available for production. And the equation of the second constraint, 2s plus 10d is less or equal to 300. Always record that soap produced must be greater or equal to 0, and detergent produced must be greater or equal to 0. We can now solve this using the graphical method or the simplest method, any of the other formula or method used in solving linear programming problems. If you still don't understand how to solve this linear programming problem, check in the video description below. There is a link to videos where we have solved questions on maximization problem. You can watch the video to get yourself more clear on how to solve maximization problems on linear programming. So after solving this, we are going to have these 4 points. These 4 points are the points that bound the feasible region after plotting your graph. Because when you plot your graph, your graph will be in this format. You have something like this as a graph and something like this as a graph. So after shading this part and this part, you have something like this. Look at point A, point B, point C, and point D after plotting your graph. So those points, look at point A, point B, point C, and point D. So at point A, the company produces, look at detergent and soap. So at point A, the company did not produce any detergent. They produced 40 soaps and they made a profit of 1,200 naira. At point B, the company did not produce any detergent and the company did not produce any soap. So they did not make any profit. At point C, the company produced 40 produce 30 detergents, and they did not produce any soap. So at point C, the company produced 30 detergents, they did not produce any soap. They made a profit of 1,200 naira, the same when they produced only soaps. At point D, the company produced a total number of 12 detergents and a total number of 19 soaps, and they made a profit of 1,610 naira. You can see that at point D, the company made their maximum profit. Therefore, the industry needs to produce 26 units of detergent and 19 units of soap to make its maximum profit of 1,610 naira. Therefore, the company needs to produce 26 units of detergent and 19 units of soap to make its maximum profit of 1,610 naira. Okay guys, always recall that anytime you are given a word problem question on linear programming, first identify whether it is a maximization problem or a minimization problem, and if it is a maximization problem, follow this format. Make a table like this: requirements, product, and available resources. Go through your question a second time. Identify the products mentioned in the question, the requirements to make those products, and the available resources, that is the resources that are available to manufacture those products. Notice that most questions we solved in this video is a word problem question of linear programming on maximization. In our next video, we are going to solve word problem questions of linear programming on minimization. Okay guys, hope the video was useful. Please subscribe to my channel. See you in the next video.